All right, picture this. You've just settled in for a long flight, you've got your bag stowed, and you're flicking through the movie options on that little screen in front of you. We've all done it a million times. But have you ever actually stopped to think about what's making it all work?
I mean, how do they get all that content to hundreds of different seats all at the same time while you're cruising miles above the ground? Well, the answer is way more fascinating than you might think. So let's get into it.
At its core, the whole system is a super tough, self-contained computer network. Yep, that's right. Every plane with seatback screens is basically flying around with its own private local area network, a LAN, that's been purpose-built to handle the crazy vibrations and stresses of flying.
To really get our heads around it, we're going to treat this like a little anatomy lesson. We'll look at the system's brain, then its nervous system, the parts you actually use, what's going on when it breaks, and of course, where all this tech is headed.
Okay, let's start our dissection. We are going deep inside the hidden architecture of what the industry calls in-flight entertainment and connectivity, or IFEC for short. You know, this system is so much more than just a movie player. It's a full-on Ethernet network that also handles things like the cabin lighting and even your flight attendant call button. It's basically a complete digital ecosystem, connecting one central brain to every single seat on the plane.
And that brings us to the most important part of the whole operation. Let's start with the brain, which is known as the head end. Now, this is not some computer sitting in a nice cool data center on the ground. No way. This is a powerful, rugged server that's tucked away out of sight in the plane's avionics bay, usually up near the front. This single unit is running the entire show for everybody.
And just think about all the jobs this thing has to do. It's storing terabytes of content. It's running on incredibly stable, often Linux-based software. It's managing the interface you're looking at, including that moving flight map. It even has to be smart enough to pause your movie for safety announcements. And to prevent the dreaded dark flight, where nothing works, long-haul jets have redundant servers. If one fails, the other one just kicks in instantly. The flight crew controls this whole thing from a master touchscreen called the Flight Attendant Panel. Okay, so if the head end is the brain, how does it actually talk to your screen, way back in seat 32A? Well, for that, we need a nervous system, and that's the distribution network. This is the system's digital spinal cord. It's this massive, hidden web of wires and routers that carries all the data from the brain to every single nook and cranny of the cabin, and it's all happening completely out of your sight. So the data gets sent through these devices called area distribution boxes, or ADBs. The easiest way to think of them is as heavy-duty routers, except they're hardwired and hidden under the floor or up in the ceiling. The cabin is divided into different zones, and each ADB is responsible for a block of about 30 to 50 seats. And right there, that's the key. This explains why sometimes a whole section of seats will go dark all at once. It's not a bunch of individual failures. It's usually just one of these ADBs acting up. And that network of nerves leads us straight to the part of the system that you know best, the hardware right there at your seat. And let's be honest, this is the part that takes the most abuse day in and day out. Tucked away under your seat, there's a little mini computer called the Seat Electronic Box, or SEB. This little guy is the workhorse that powers the screens and crunches the data for your small group of seats, usually a cluster of 2 or 3. And yes, that is the box. You know the one I'm talking about, the one that's always fighting with your feet for legroom. It's an absolutely crucial piece of the system. But the good news is, designers are working on new ways to build all that tech right into the screen itself to give us our legroom back. Now, connected to that box are the parts you actually touch. The screen itself for a seat display unit, which can be a gorgeous 4K screen nowadays, and the remote control, which is called the passenger control unit. And because these parts are right out in the open, they're the ones that break the most, whether it's from spilled coffee, getting knocked by luggage, or just that retractable cord on the remote finally wearing out. Okay, so now that you know the whole anatomy, you can pretty much be an expert troubleshooter on your next flight. Let's decode what's actually happening when your screen starts to glitch out. We've all been there, right? Your screen is totally frozen, but the person next to you is watching a movie just fine. Or maybe your screen and your immediate neighbors are all out. Or worse, what if rows 10 through 20 are completely dark? What is going on?
Well, here's your cheat sheet. The scope of the failure tells you exactly what broke. If it's just your screen, try holding the power button. That'll trigger a soft reset you can do yourself. If your screen and the 2 seats next to you are out, that's a classic sign of a seat electronic box issue. The crew can try to reset that from their control panel. Now, if a whole zone is down, say half of the economy cabin, that's an area distribution box problem, and only ground maintenance can fix that. And if the whole plane goes dark, that's a head-end server failure, and the crew has to do a full system reboot that can take a solid 20 minutes.
And here's a little insider secret for you. You might think, why not just go flip a circuit breaker in the cockpit for a hard reset? Well, crews are strictly warned not to do that. Using a breaker can actually mask a much more serious underlying problem, like deteriorating wiring, which is a much, much bigger deal than your movie freezing.
So, with all this complex, heavy hardware, where is this technology actually headed? Well, the future is all about two things: losing weight and cutting the cords.
The biggest shift we're seeing is to wireless IFE, where you just stream movies to your own phone or tablet. And this comparison shows you exactly why. A traditional wired system costs millions, adds a ton of weight, and burns more fuel. A wireless bring-your-own-device system? It costs a fraction of that, weighs almost nothing, and is way easier to maintain. It's really a no-brainer for airlines.
And if we look even further down the road, some airlines are already experimenting with virtual and augmented reality. I mean, can you imagine just putting on a headset and having your own private, immersive movie theater, completely shutting out the rest of the cabin?
So the next time you get on a plane, you'll see more than just a screen. You'll know the whole hidden story playing out behind the scenes. The brain in the avionics bay, the nerves running under the floor, and the interface right at your fingertips, all working together to make your flight just a little bit better.
Which really just leaves us with one final big question to chew on. As all of us carry these incredibly powerful screens in our pockets, and as wireless streaming becomes the standard, is the seatback screen actually doomed? Will we one day look at it and think it's as old-fashioned as an ashtray in the armrest?